So on the last part of the lesson, we were looking at all of our different types of transformations, and we are going to summarize that on the next page. What are our different types of transformations? But on this page, we're going to talk a little bit more about parent functions. So parent functions are the most simple function of a certain type. Types of functions we use most in this course, and we will have some more to add to it. We use linear functions, absolute value we'll talk about, quadratic we've talked about a bunch, square root a little bit, but we'll talk about them more, cubics, you might see some cube root functions, probably not as much this one, rationals, and then later I'm going to put an L here on both of these two will come up. I like this chart, it just shows different types of functions, and each of these functions is the simplest of its type. So for example, the simplest linear function is y equals x. The simplest absolute value function is y equals absolute value of x. The simplest quadratic function is y equals x squared. So now that we start to talk about transformations, we call these parent functions because this is the simple one, and then by making those function changes, we can move the parent function, the original function, to different locations on the graph. So now we have that. We talked about the cubic parent function in the last lesson, x cubed, as well as the square root parent function, square root of x, and we will be talking about them more as we go on. On this page is where we're going to summarize those transformation rules. Now on this video, I'm not going to do it. We're just going to kind of use what we did from those first two pages, but in class I would probably show this. And we also did a page of this in the last lesson, kind of just talking about how they look. So to summarize, anytime that I take a function and I make the x negative, that's a reflection in, sorry, I'm a little slow writing, in the y-axis. Remember, it's the opposite of maybe what we would think. And negative f of x, if we make the y negative, that reflects, I'm going to abbreviate this, in the x-axis. So the group of transformations here is just our reflections. Because when we group them, it's a little easy to remember them. The next two ones are our horizontal shifts, right? If we change the x value by adding or subtracting. Now they work a little bit opposite of what we think. So this is left, right? When it's plus, it's left. Remember, factors, opposite of the sign. For the root, left, a units. Trying to put quotes around that. Sorry. The next one, I'm not going to use the quotes again, but you guys get the idea. We're just taking whatever number is plugged in for a. So the next one is right, a units. And those two together make up our horizontal, so back and forth shifts. F of x plus a and f of x minus a, it sounds almost the same as the other ones when I say it, but if that a is outside of the parentheses, those are our vertical shifts. So plus a moves it up a units. Remember, these work as expected, the changes to the y's. And this one is down a units. So those are our vertical shifts. And lastly, this says a times f of x, where a is greater than 1. So if we put a number greater than 1 in front of the function and we multiply it, that is going to do a vertical stretch of a. And if the number is between 0 and 1, if it's negative, just a side note, that means there's also a reflection involved, like this, okay? But if it's a number between 0 and 1, so 1/2, 2/3, 0.7, anything that's between 0 and 1, that's a vertical compression of a. That's short for compression of a. So this section are our vertical stretches / compressions. So to end the lesson, a lot of this lesson is exploratory and we have a second day of transformations. We're going to take a parent function and we're going to write what changes would happen based on that chart and what the new function would be. So the parent function we're starting from here is absolute value of x. So we use a of x for this one. That's just the function notation that was picked. If I want to take a of x and move it right 3, based on my function rule, that's a of x minus 3. How that would look as the function would be absolute value of x minus 3. And if you go back to the previous lesson, that's kind of where we went over to how to plug things in for x if you need to look at that. We're not simplifying. You really can't do a lot of simplifying with absolute value anyway. Reflection in the x-axis. So this is the opposite, right? I need negative a of x, as in making the y value negative, not the negative on the x. So this is negative absolute value of x. A shift down 2 would be a of x minus 2. So that's the absolute value of x minus 2. A vertical stretch of 3 would be 3 times a of x. So 3 times the absolute value of x. And as I said, this part has just as much to do with how comfortable you were with the last lesson. You'd really just take the rule and then use what you learned last lesson about writing functions. So if you're having trouble with that piece of it, like how do I write them once I write the function notation, that's more last lesson to look at. Reflection in the y-axis, so that's a of negative x, right? If I'm reflecting in the y-axis, I make the x negative. So that's absolute value of negative x. And then shift up 3, or left 3 up 4, so that's a of x plus 3 to go left, plus 4 to go up. So x plus 3 goes in absolute value, plus 4 goes on the end. And a vertical compression of 2 is 1/2 a of x. So that's 1/2 times the absolute value of x.